Hello, and welcome to Planning the Solution. We're going to do something a little different here. We're not going to go through a slideshow like you have been in the past 4 or 5 presentations. We're going to kind of work out a problem together now. So please follow along, sit back, and kind of see if this makes sense to you. I have 3 different problems we're going to solve, and I'm going to put them in 3 different presentations so you can refer back to them very easily. The first problem will be a very simple, hopefully a little fun problem. And if you look at this, it basically states, write an algorithm to brush your teeth. That's kind of a broad statement. It's something that we kind of do every morning, and in a lot of ways practice logic and common sense to do so. So let's see if we can actually figure this one out as we go through it. I sort of got started on a couple things here so we don't bore you to death on this one. And if we look at it, what's our inputs? As I told you before, we need to actually look at the problem, determine our inputs. Now in this case here, we don't have a lot of things defined to us, so many of our inputs are assumptions, correct? So what we need to be able to do is we need to ask our user what our inputs are. So we'll go ahead and form some assumptions and verify with our user. In this case, your user will be me, and so everything I put down as an input is true. In this case here, our inputs are a toothbrush, toothpaste, and water. Our outputs. Our output in this case is basically going to be clean teeth. All right. So that's what our goal is. Assumptions. Any assumptions? Any thoughts on what assumptions might be? Maybe one might be is, when do we know we have clean teeth? After we put toothpaste to them? After a minute of brushing? After 4 hours of brushing? Well, that's a great assumption, and one that we really need to nail down with our user. In this case, we'll say after 5 minutes of brushing. Whoops, sorry. After 5 minutes of brushing. Any other assumptions that we need to verify with our user? I don't know. I don't know if there's much here. And we can probably go on and on and on. Maybe you're thinking of some right now. Let's kind of keep this pretty simple for our very first exercise here. The other thing I told you have to go do is high-level task. What's the high-level task by taking our inputs and being able to obtain our outputs? Well, very simply in this case is brush your teeth. All right. So under brush your teeth, we need to define it utilizing our pseudocode and utilizing our structures of programming. So where do we start? That's always a great question, right? What's the very first thing we need to do? We probably need to go get our inputs. It's always the first thing that might be good. So what we need to do is get toothpaste, toothbrush, and water. In this case, we're going to say turn on the water. Well, let's just say, matter of fact, let's do it this way. Let's just go get our toothpaste and our toothbrush. Now we have those two. And we're at the sink. We'll assume we're at the sink. There's some more assumptions. Where are we? Are we in the bedroom? Are we out in the garage? In this case here, our user is going to tell us that you're at the sink, ready to brush your teeth. Again, this problem can go anywhere. All right, so we're at the sink. What's the first question we may ask? Now that we got these things, what are we going to do? Some of you might say, well, put the toothpaste on the toothbrush. All right. Now what? I know what I like to do. I always like to take the toothpaste. I think it goes back when I was young. I always put the toothpaste on the toothbrush and then put it under the water. I know it's supposed to go the opposite way, but I think I was always trying to somehow get the toothpaste off the toothbrush. Probably not a good thing. Probably why I have too many cavities. Nonetheless, in this case here, we probably need to put the toothbrush under the water and wet it down a little bit. One question we may ask is the water on? We may have that as an assumption to our user, but our assumption would be, no, the water is not on automatically. So we might have to ask the question, if the faucet is on, let's do it this way, is off, then, I'm going to capitalize our little structures here so it's a little bit easier to read. If the faucet is off, then what are we going to do? Well, we're going to turn on the faucet. Pretty simple. After we turn on the faucet, what are we going to do? Well, then we'll probably wet the brush. Right? What will we do if the faucet is already on? Well, we probably would wet the brush still, correct? And then end if. Alright, that's cool. One thing you might want to notice with that is that we have some repeating code here. Meaning, if the faucet is off, turn it on. No matter if it's on or off, we're still going to wet the brush. So how else could we have written this? Very simply, what I might do is I might take my end if, and I might come up here and go ahead and end that structure. And then instead of having an else there, I will just go to the very next statement. You see that? So we got the toothpaste, we got the toothbrush, we put some toothpaste on the toothbrush, we asked if the faucet is off. If the faucet is off, go turn on the faucet and then basically wet the brush. The else is assumed here. The else is basically stating, well, the faucet's on. So go ahead and wet away. Alright. As you can see, top-down logic. We're drawing an algorithm. So what's our next thing we need to do? Well, now we wet it, so we start brushing. Now, as I stated before, we want to brush for 5 minutes. So how would we do that logically? How would we set that up logically? Think about that yourself. When you're brushing your teeth, and let's just say you always assume you want to brush for 5 minutes, what are you constantly asking yourself? In a sense, what you're constantly asking yourself, you're probably not aware of it, is, has it been 5 minutes? 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 What do we have there? Yep, we have a loop. So, in this case here, what we can say is, do until 5 minutes. And then what we want to do is brush, brush, brush. Loop. Now let's think about this. So all we need to do is we got the toothpaste, we got the toothbrush, we put the toothpaste on there, we seen the faucet was on. If it was, we wet the brush. And then we're basically going to say, for the next 5 minutes, this is going to be a very fast loop we're brushing. So do until 5 minutes, brush. I shouldn't confuse you by putting 3 things there. We brush, we loop. Has it been 5 minutes? No, keep brushing. And that thing just keeps going on until we hit 5 minutes. Once 5 minutes is done, we stop. I don't know, what do we do next? I guess we probably rinse, right? Rinse off our brush. I gotta learn how to spell. Rinse, rinse brush, put brush away, wipe our mouth, and then we're done. Does this work? That's your next question. Does it work? How do we know it works? Well, you could probably go test this little algorithm yourself and brush your teeth right now if you like, or we can just kind of walk through it. So let's walk through it real quick. We get the toothpaste, we get the toothbrush. We put the toothpaste on the toothbrush. If the faucet is off, then turn on the faucet. If it's not off, if it's already on, go ahead and move on. We wet the brush. We brush and we loop for 5 minutes. Once 5 minutes is hit, we rinse. We rinse the brush, we put the brush away, and we wipe our mouth. Looks like it works to me. Do you see that logic? It's top down. Now, if we did something silly like put the brush away up here, meaning, well, Bob, I have the code out there, and I just said I just put it right there. Again, it won't work. I mean, to put the brush away first doesn't even make any sense. The computer does not understand what you're trying to do. You have to tell it step by step. Anyway, I know this is very simple and in a lot of cases kind of a silly problem to do, an example, but for the most part it works. It's common sense logic, and what I'm trying to do here is show you that you use common sense every day. For some of you out there who are thinking, I don't know if I'm logical enough to do this class or do this programming, yes you are. You do logic every day. What we need to be able to do is put logic in a format that is an algorithm that somebody else could use this. Maybe what you can do is take this algorithm, give it to a kid, and see if he actually brushes his teeth by following the instruction one by one. If you recognize that he's brushing his ear with it, we got a problem. Maybe that's something we don't have up there. We wet the brush and we brush. We never say wet the brush. Maybe we should say wet the brush, put brush in mouth. Yep, I like that because, again, the computer doesn't know what we're trying to say. So if you give this to a kid and we say brush, he might start brushing his ear. So we need to be very specific with everything we state, task by task, one by one, and we do it one at a time until this task is finished, and then we move on. Finally, what structures did we use here? Well, we got sequential structures. That's a sequential structure. That's a sequential structure. We have a conditional structure. If the faucet is off, then do this. We have more sequential structures in here, and we have an iterative structure. We used them all, and that's all it is to do. All right? So this is our first example. Please go ahead and repeat this if you want to go through it and kind of give it an idea of what we did before. Or not, go on to our next example in the next presentation.